Okay, Assalamualaikum warahmatullahi taala wabarakatuh. Okay, this is part 3 of discussion on the beam analysis using moment distribution method. Okay, this is part 3. Okay, in my first video, I have opened the session with discussion about the process, the procedure, the analysis of the beam, okay, of this beam. So I have explained how we calculate the stiffness factor, the distribution factor, and then the fixed end moment, and after that followed by the moment distribution. Okay, the detailed process on how to distribute the moment have been discussed in my second part of this video. Okay, and this is the third part, okay, where we have already determined the member end moment for the beam using the moment distribution method. Okay, so as I mentioned in my previous video, okay, these are all the moment value, the member end moment or internal moment. Okay, and this moment can be used straight away to draw the bending moment diagram, because the member end moment is actually the internal moment, and the internal moment is actually the bending moment value. So using this value, we can draw the moment diagram or the bending moment diagram straight away. Okay, so I will show to you the simple step on how to draw the bending moment diagram. Okay, this is just to show you the simple steps on how to draw the diagram. Okay, so this is the moment that we have determined here. So this is the moment. Okay, this is all the moment, member and moment. Okay, so for each member, we have 3 members: A, B, and BC, and CD. 3 members. We have 3 members. Okay, so so these are all 3 members: member AB, member BC, and member CD. Okay, so member AB, so we label first the member. So this is A, B, C, and D. Remember that BC has UDL and point load at member CD. The value is 30 and 200. This is 30 kilonewton per meter and 200 kilonewton. Okay, we have determined the moment. So now we'll look at this value. Okay, look at the sign first. Okay, if the sign is negative, so we will draw the negative moment direction. Okay, negative mean counterclockwise, because our sign convention for this beam is clockwise positive. So it is negative, positive, and negative, positive. Okay, I repeat again, it is negative, positive, negative, positive. Okay, remember that this time I want to show to you how we want to draw the bending moment diagram in a simple step. Okay, again, we will start with looking at the sign. Okay, negative negative for AB, positive positive for BC, and negative positive for CD. Okay, negative negative, so we draw the direction. It is negative 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 negative. Okay, then positive positive, and then last one is negative positive negative positive. Okay, so this is the moment direction, this is the moment direction. So negative means, hello, yeah, okay, warna pink tu, yang tu ambil balik kat PUTM. Oh, Faizal tak PUTM? Faizal tak kat guard boleh tak? Oh, tinggal pink tu je. Oh, Faizal tak PUTM lah ni. Oh, tak apa, kau start suruh pergi situ kau ah. Okay. Okay, so again, so I want to draw the bending moment diagram, right now. Okay, I will show to you how to draw the bending moment diagram using simple step. Okay, step number 1. Okay, I will draw the beam. Okay, I will draw the beam like this. Okay, there are three members, member AB, member BC, and member CD. Okay, there are 3 beams. Okay, so member AB does not have any load that is applied on the beam. Member BC has UDL, and member CD has a vertical load. Okay, so by looking at the moment value that we get from the table, so MAB MBA is negative negative, so we draw the negative direction at A and at B. MBC and MCB is positive positive, so we draw the positive direction. And MCD is negative, MBC is positive, so we draw the direction. Okay, the direction, one negative, one positive. Okay, so now I want to show to you what is the step to draw the diagram. Okay, this is step number 1, step number 2. Okay, step number 2, I will draw the diagram separately, member by member, so that you can see clearly how the actual process of doing this. Okay. Okay, so now please look at the arrow. Look at the arrow. Okay, at A, the arrow is okay, the arrow for AB. Okay, the arrow for AB. So I will draw the different diagram so that you can see clearly the different diagram. So I will draw here AB. This is AB, this is BC, and this is CD. Okay, there are 3. There are 3 members. Okay, I want to draw. I want to put Okay, the dot, I want to put the dot, okay, for the diagram, the dot. Okay, the point means the point, the moment point, for the moment position, where is the dot is located. Okay, by looking at A, the arrow shows the below direction, the below line. Okay, this is the line, this is the line, right? Okay, this is the line. Okay, at A, the arrow shows the below line direction, so it is located here, somewhere here. Okay, we just put the point first, the dot first. Okay, at B, the arrow, okay, show that the point is located at upper part, okay, upper part of the line. Okay, one is below, one is upper. Okay, the point is here. Okay, and for BC, we just follow the arrow, the point is here. Okay, and for CB, the arrow is, shows the below part, so it is somewhere here. Okay, doesn't matter, we just sketch only. The most important thing, we want to know where is the position, whether it is negative or it is positive. Okay, for C, we'll follow the arrow, it is below line. Okay, and D, it is below line. Okay, so now we have already, okay, get the point of the bending moment diagram. What we need to do now is to join all this, okay, to draw the complete bending moment diagram for each member. We do it member by members, separately. Okay, separately. Okay, remember that for the diagram, we should start from 0 and end at 0. Start from 0 and end at 0. Start from 0 and at 0. Okay, start from 0 means here is 0. Here is 0. This is 0. Okay, so 0. Okay, join with this one. Okay, and since there is no external load on member AB, so we just have to join these two dots. Okay, and then we must close this diagram. Okay, the diagram must close at 0 and at 0, so here. Okay, so as you can see here, this is the bending moment diagram for member AB. The value is 10 and 20, 10.45, 20.992. So the value is 10.45, 20.992. Okay, 10 is negative, 20 is positive. Okay, don't worry if you find that why this is too positive. Negative 10 is positive, negative 20 is also positive in the table. Okay, and why here when I draw the diagram, okay, the one position is located at negative side and one position is located at positive side. Okay, it must be like that because remember that the negative, the signage shown in the table shows the moment direction. Okay, here shows the moment direction here. This is the moment direction negative. This is the moment direction negative. After that, from the moment direction, we will determine where is the position. Okay, where is the position of the moment. Okay, whether it is located below line or upper line. Okay, so normally what I can conclude is for two value, we have value MAB and MBA, right? So we have MAB and we have MBA. And in the table, MAB is negative 10.45 kilonewton meter. and MBA is equal to negative 20.992 kilonewton meter. This is in the table. Okay, in the table. So please remember that, okay, for the diagram, we must start with zero value. We must start at zero value, means that here, okay, this is the zero value. Okay, 0, we minus negative 10.45, so we get negative. Okay, and then here is 20.992. To close back to 0, this positive, whenever positive 20.992, positive 20.992 plus with this one, we will get back to 0. Then we get back to 0. Okay, so this is the bending moment for member AB. This is the bending moment for member AB. Okay, so now we want to try to draw the diagram, the bending moment diagram for member BC. Okay, as I have explained just now, we have to look at to the moment direction. Okay, we will first start the moment direction. We get the sign from the table and we draw the moment direction. Okay, the value we will be put, okay, later. Okay, so the first, here we will draw like this. Okay, start from 0 means we will continue this line like this and like this. However, for this one, okay, since this is UDL, this is UDL, okay, we must consider, okay, we must analyze what we call that. We must analyze whether this beam has maximum moment or not. Okay, in order to do that, we have to draw the shear force diagram at member BC. Okay, we have to draw the shear force diagram at member BC. So how to do this? Okay, so I move to next page. Okay, in order to determine whether the, okay, for UDL, okay, we must determine the shear value. Okay, the shear value. So we will analyze like this. This is the beam. Okay, here will be the BY and CY. Okay, BY and CY. Okay, UDL, it is 30. This is 30, right? 30 kilonewton per meter and 4 meter. So the moment is positive. The moment is positive. And the value is 20.992, 50.533. 20.992. This is 20.992, 50.533. Am I right? 533. Okay. Okay, this step will be because we are going to determine whether the beam has maximum moment or not. Okay. So this is the what we call this free body diagram for member BC only. This is what? This is, okay, this is, okay, free body diagram for member BC only. Free body diagram for member BC only. Okay, member BC only. Okay, so now we need to calculate the BY and CY value. BY and CY value. Okay, BY and CY value. Actually, this is BY2 and CY1. Okay, so this is the process. Okay, I will explain to you about this free body diagram in the next video. Okay, for this one, I will focus on how to determine the the value first. The value, the whether we want to know whether it okay, this one has a maximum moment or not, in order to draw the correct shape of the bending moment diagram for member BC. Okay, so by having this as the as the free body diagram, we will analyze using static equilibrium to determine BY2 and CY1. Okay, using static equilibrium by taking moment at C is equal to 0. This is the basic thing that everybody in this field must understand. Okay, so by taking moment at C. Okay, it is 20.992 plus 50.533 towards C. So negative 30 times 4 times 2 plus BY2 times 4. Towards C, towards C it is negative, positive. Okay, this is equal to 0. So we solve this. So it is 20.992 plus 50.533. Okay, minus 30 times 4 times 2. Okay, divide by 4, we get 42. Okay, BY is 42.12. BY2. So using total Fy is equal to 0, we will get BY2 plus CY1 minus 30 times 4 divided by equal to 0. So we get CY1 equal to 30 times 4 minus minus 42.12, and this is equal to 120 minus 42.12, 77.88 kilonewton. Okay, so we will draw the shear force diagram for this beam. For the shear force diagram, shear force diagram for member BC. Okay, here shear force diagram. Okay, the reaction is 42.12. Okay, this is 34 meter kilonewton per meter. Okay, it is CY1 is 77.88 and 42.12. The moment is positive. Okay, positive doesn't matter, because we just want to focus on the shear value in order to draw the shear force diagram. So for the shear force diagram, okay, it is 42.12. Start from 0, we go up. 0 go up, and then minus 120, we get negative 77. So somewhere here, so we go up, and then this is the Okay, this is the shear force diagram. This is the shear force diagram. So this is positive, this is negative. The value is 42.12 here and 77.88. So kilonewton. Okay, so this is the shear force diagram. The intersection in the shear force diagram means that there are maximum moment in bending moment diagram. Okay, this is the shear force diagram. This has maximum. This has intersection. Okay, means that we have to find the area of the triangular of two triangular, and in order to do that, we must know this value as well as this value. Okay, so how to determine this? We will determine this length value from the force, because remember we want to determine the length in unit meter. We want to determine the length in unit meter. So if 42.12 kilonewton, the kilonewton we divide by kilonewton per meter, we will get meter. Okay, kilonewton per meter, we will get the length in unit meter. So it is 42.12 divided by 30. So we will get length. Okay, this length as 1.404 meter. And the remaining is 4 minus 1.404. It is 2.596 meter. Or we can also get 2.596 by using 77.88 divided by 30. So we will get the same, 2.596. The total length must be equal to 4. Okay, so this is the intersection, and we have already determined the length, and the height is the shear value. So we will continue draw the bending moment diagram. Okay, so the value here is 20.992 is positive. 20.992 is positive. The next value is 50.553. Okay, it is 50.553. Okay, now we want to check whether we get or not the 50.553 using the area of the shear force diagram. Okay, so we will start with positive 20.992 plus the area. Okay, the area is 0.5 times 42.12 times 1.404. It is equal to, okay, the maximum moment in the bending moment diagram is 50.56. 50.56. So 50.56. So somewhere here. Okay, 50.56. Okay, the distance is about 1.404. Okay, this 50.56 we have to minus with the area. Okay, the area of this. Okay, so minus, because why we need to minus? Because it is the sign in the diagram is minus. Just now we have to plus, because the sign in the diagram is plus. Just now, okay, now we have to minus. So 50.56 minus 0.5 times 2.596, okay, times 77.88 equal to 50.53. Okay, negative 50.53. So then, okay, again, this is correct. This is negative 50.5. Okay, 50.5. Okay, it is about the same. Okay, so what we need to do is here, since BC has UDL, so UDL for bending moment diagram, we must draw the curve line. So we have to draw that. Okay, we draw the curve, yeah, curve. Okay, curve like this. Curve line. Okay, draw the smooth as you can. Okay, so this is the diagram, the bending moment diagram for member BC. The upper part is the positive side, and the lower part is negative. Okay, so MAB from the table for checking, MBC and MCB. MBC is positive 20.992 and MCB is positive 50.553, because okay, whenever we plus these two value, negative and positive, we get back to 0. So this is the shape of the bending moment diagram. The diagram, the bending moment diagram for member BC, the upper. Okay, so we continue to the next beam, member CD. Okay, we continue to the next beam, member CD. Okay, so this beam has loaded with a vertical load at the center of the beam. Okay, only UDL has the curve shape of the bending moment diagram. For CD, we will have the what we call that, the straight line for CD. Okay, the straight line. Okay, so basically the CD, okay, to get the accurate one, we have to draw the shear force diagram first. However, this is the standard shape of the shear force diagram, where the shear force diagram for this one will be like this. Okay, will be like this. The diagram will be somewhere like this. Okay, so means there will be the point here. Okay, the point right here. Okay, the point right here. So, and we need to join the dot. Okay. Hilang. Pipi ambil balik. Okay, so here is like this. Okay, we just join this line and this line. Okay, so this is the shape for bending moment diagram for member CD. Okay, the maximum moment just now we determine. I forget to put the value, so we can put the value of moment here, the moment. Okay, here also have the maximum moment. Okay, so this is negative, positive, negative, positive, negative. Okay, so the value is, so MDC is 50, negative 50.553, and the last value is 87.24. 87.24. So this is 87.24. So this is 50.553 and this one is 87.24. Okay, remember, one is negative and one is positive, because whenever we total this, we will get zero value. Okay, this is how we draw the diagram. Tibuh lain. Okay, this is kilonewton meter, kilonewton meter, kilonewton meter, kilonewton meter.
Dah habis. Dah ulang ni.
Ambil dan kat bawah. Kak Ibu nak kat Ibu.
Tapi dia tak bagi dah.
Boleh. Jangan buka. Dia rosak.
Tapi dia tak bagi dah.
Kita bagi sudah. Okay. So this is the this is the bending moment diagram where we do it separately. Okay, I do it like this in order to guide you the simple process on how to draw the bending moment diagram. So next time whenever you do exercise, okay, after the bending, after you have determined the moment